This module of the course deals with physical database design. The chapter on this topic is Chapter 5 of the main textbook. In this chapter, we are going to discuss the basic steps to develop an efficient physical database design. During the physical database design phase, you are going to make choices about the hardware and the software you will use for the database application. You will also make decisions about data storage structure, indexing, and data retrieval methods. The decisions you make during the physical database design will have important implications to data accessibility, quality, security, and the response time. So it is not something that should be taken lightly. The first key concept you will need to understand in this module is the distinction between logical database design, which was discussed in the previous module, and the physical database design. The main distinction lays in the focus of these two types of database designs. Logical database design focuses on representing the critical data elements, their relationships, and the business rules from the business perspective. In other words, the data model resulted from the logical database design represents how business people view the organization and its business processes. On the contrary, physical database design focuses on system issues such as performance, integrity, and security. We go through the physical database design to ensure that the final database application will meet the desired performance, integrity, and security requirements of the business. So both logical and physical database design processes are equally important. Chapter 5 presents the basic steps that are required to develop an efficient and effective physical database design. Physical database design is very important since it immediately impacts those factors that are important to the end users, such as data integrity, security, response time, user friendliness, and so on. This step is where the rubber meets the road, since regardless of how well previous steps may have been completed, users will not be happy with the sloppy physical design because the user cannot retrieve the data easily, accurately, timely, or in the right format. So in this chapter, we'll first present a simple approach to estimate the volume of data in a database, as well as the probable data usage patterns. This is an important ongoing task for database and data administrators. Databases are not static, especially in today's environment. They are living beings and often expand in size and changes usage patterns more quickly than you think. A database or data administrator need to continuously fine-tune the database performance based on the changes in data volume and usage. We will then discuss issues associated with defining fields, including data type determination, coding, and compression techniques, controlling data integrity, and handling missing data. These issues may seem somewhat trivial in the grand scheme of database design to some people, but mishandling them can result in very severe consequences. Issues such as default values, range controls, no-value controls, referential integrity, and missing data have profound impact on the overall data integrity of the database. You need to understand how each of these issues needs to be handled in various situations to improve data integrity in the long run. We will then discuss designing physical records and include an expanded section on denormalization. Denormalization, as the name suggests, is obviously the reverse of normalization process that we discussed in the logical database design. So why spend the time normalizing and then undo it in the following step? Well, that's a great question for you to consider when you go over this chapter. The answer lies in the distinction between logical and physical database design. Denormalization is an effective and widely used technique for improving database performance. However, denormalization should not be abused. A database administrator must weigh the performance improvement created by denormalization against the potential data integrity risks. So a key issue to consider about denormalization is the situations in which denormalization is recommended and the situations in which it is not very useful. Like denormalization, vertical and horizontal partitioning are also techniques for performance improvement. Besides understanding their benefits, you also need to be aware of their costs and risks. As you have probably found out by this point of your study, database design is a balancing act. One must balance between an organization's need for database performance and the need for data integrity and security. This chapter also describes the basic file organizations and the trade-offs that are typically involved in selecting a file organization. The discussion on the use of indexes is especially interesting. File access performance is discussed, including the discussion of RAID technology. Appendix C of the textbook provides a discussion on data structures. Although many modern database management systems hide the underlying data structures, the tuning of a physical database requires understanding the choices a database designer can make about data structures. While the topics in Appendix C will not appear on the exams, you should have some basic knowledge about data structures. The chapter concludes with a comparison of available database architectures, including the legacy database architecture, such as hierarchical and the network databases, and the more contemporary relational, object-oriented, and the multi-dimensional data models. The key issues to understand here are the legacy database architectures still have their places in today's database systems, and that object-oriented and multi-dimensional architectures are gaining traction with business applications today. Although the database topics are discussed from the relational database perspective in this course, you should understand that relational database is not the only choice when it comes to building a business database solution. Legacy database models offer exceptional performance when they are used in systems that have well-defined functions, but they lack the flexibility that's often needed in today's dynamic business environment. Relational model offers great flexibility and is quite suitable for supporting both transaction processing and decision support. Yet, it lacks the performance that real-time business intelligence systems may require. While as computer technologies improve, this performance gap is rapidly narrowing. At the same time, the amount of data we deal with is also rapidly expanding. So the traditional relational data model still represents severe limitations when it is used in business analytics systems such as data warehouses. Multidimensional data models, including the star schema and the snowflake schema that we will discuss in the future chapter, are extensions of the relational model, but they are designed to handle large volumes of data efficiently. So as you can see here, which data model to use is a critical decision that will impact the future performance and the scalability of a data repository. After studying this module, you should accomplish the following learning objectives. You should understand the differences between logical and physical database design, And you should understand the key decisions you need to make in physical database designs, their inputs, and their deliverables. You should also understand the process of denormalization, which is a widely used technique for improving database performance, especially in the relational database setting. And finally, you should also understand the types of file organization and the different database architecture in order to make the right decision about which database architecture to use for your particular application. The assignments that I have assigned to you should be very helpful for reviewing the most important topics covered in this module. Please complete the assignments and submit them on time, and I will go over the common mistakes found in your assignments with you after grading them.